Okay, I think we can get started. 3 minutes pause. I see already quite a few people in. So welcome everyone. My name is Pablo. I'm going to be your instructor today. We're going to be talking about ClickHouse, but mainly how to migrate data from BigQuery to ClickHouse, like what to think about, why migrate from BigQuery to ClickHouse. And yeah, we are going to use the chat hopefully often. So if you have any questions, feel free to type in there. I'll try to keep an eye on it and answer as many questions as I can. Um, what else? This is being recorded. The recording is going to be available probably tomorrow or the day after. I'll give you more details later as we go through the course. Before we start, I'm going to start a quick poll, which just vanished from my, yeah, here it is. So it's really interesting for us to understand a little bit more of people attending training. Like, you are they like ClickHouse users already? Are they just getting started with ClickHouse? What are the use case you're coming from? Like things like that help us shape the training and give you a better experience. So that's why we like to start with a poll. So if you can take a few seconds to just click on a few buttons, that would be great. I'm in the ClickHouse training team. I've been with ClickHouse for about, I don't know, 8 months now. And I worked in a few different companies prior to that, but always related to data analysis, basically playing around with data, like trying to make sense out of data, doing some analytics and stuff. Within the training team, we try to create new content, deliver content as often as we can, and basically just get people to really understand ClickHouse and use ClickHouse in the best way possible for them. Okay, so mostly some idea of what ClickHouse is, a few more experts. Okay, interesting. Main use case, real-time analytics by far, business intelligence, and yeah, some people interesting. This is a BigQuery and 70% of the crew actually are using like Postgres, MySQL, and MongoDB. We should run the migrating from PostgreSQL soon. Okay, I'm ending the poll and I don't know, download results. I think that's what I need to do. Great. Right, I'll take care of that later on. Thank you for listening. So let's get started. This is what I'm going to cover. I'm going to talk a little bit about why migrate from BigQuery to ClickHouse, the main differences, talk a little bit about schema design, data modeling within ClickHouse. It's quite a peculiar database, so there are a few important things that you should know. And then I'll just go through some closing remarks. So we're here to talk about migrating from BigQuery to ClickHouse. So it's very important to like set the context in terms of, okay, what is BigQuery, right? Uh, it's a fully managed serverless enterprise data warehouse, right? And the main focus here should be on the serverless part. No underlying hardware, no need to choose node, size, CPU, like complete separation between compute and compute. So you just go, you write a query, boom, it's going to run. You have no idea how it's running, where it's running, what's happening, and it gives you a result sometime later. Okay, and that's also important because I'm going to be stressing that part very often, that the sometime later in BigQuery, it's usually quite too long for real-time analytics, right? You have no dedicated compute resources, so it can be slower to warm up. It's not that you know what you're paying for. So you're basically charged for the slot time that consumed by the queries you're running or the size that you're reading, like the amount of data that you're reading. It's really, really hard to estimate costs. Small query, like they can, I don't know, like if you change a query and you suddenly forget a where clause, you might just be running this like crazy query that takes a long, long time and just costs you, I don't know, $300 because yeah, you forgot or you changed something you didn't know. So that's what we see as a great motivator for people to actually look out of just the BigQuery world, right? And that's what we are going to be talking about a little bit. So ClickHouse, what is ClickHouse? ClickHouse is a column-oriented database. It's an open source database, and it enables users to generate powerful analytics, right? Just using SQL queries the same way that you do with BigQuery, but in real time. And yeah, real time is really important in many cases, and hopefully I'll make my case later on. It's free, it's open source, you can download, you can use it, but then you have to manage yourself. Sometimes managing it yourself can be more expensive or just deviate your focus from what really matters. So we also have ClickHouse Cloud, right? Is a service offering very similar to the way BigQuery is also a service offering in the cloud, but it gives you dedicated scalable infrastructure per cluster. So whenever you define a service within ClickHouse, you have allocated for you a dedicated infrastructure, right? You know exactly what you're going to pay at the end of the month for that infrastructure, and you can use it as much as you want, right? You have full resource control. You can define the minimal amount of the minimum size of the infrastructure, the maximum size, so we can scale automatically within those boundaries, right? So no cost surprise, very steady, very reliable, very predictable. And very important, ClickHouse was built to be the fastest analytics database out there. So every feature, everything we discuss around ClickHouse, we are always stressing speed. That's really what we care about. We care about queries being really, really fast. We care about your insert having the throughput you need, right? So here's trying to summarize it in a table. So both are analytical processing databases. So they were built to basically for you to run analytical queries. BigQuery is focused on querying vast data sets. That's great. But ClickHouse focuses on efficiently querying vast data sets and being really, really fast when doing it, right? So the overall higher latency that you're going to have in BigQuery is often a problem, especially when you have highly concurrent workloads. So a lot of people accessing the data, running queries concurrently in parallel, that usually doesn't scale well in terms of speed, but also in terms of costs. ClickHouse is going to be more limited when we're talking about transactional heavy workloads. So if you really care about asset compliance, transactional workloads, doing a lot of joins and running ad hoc queries, then ClickHouse was not built for that. And you're going to probably find some limitations in there. In terms of cost, BigQuery will have higher costs when actively querying. So a very common use case that we see of people like having a problem or reaching a limit within BigQuery is they actually want to give users the power to run their queries. They want to have people like really looking into the data, and then costs become higher and higher and higher because you're charged by the query, right? On the other side, if you just have ad hoc queries, you run a query here, you run a query there, and that's what you really need, then BigQuery is probably what you're looking for because you're not worried about speed and you don't have this high volume of queries, right? So ClickHouse, the cost might be higher when you have like those few queries because you have the infrastructure allocated to you. And if you're not using that infrastructure, then what is the whole point? We do have an idle setting that basically idles a service after, I don't know, 10, 15 minutes or an hour or 3 hours. So if no one is using it, nothing is running, it just shuts down. And then whenever you try to query again, it wakes up the service, which might reduce the cost that you actually have at the end of the month. But that's not what people are looking for when we're talking about real-time analytics. Yeah, is everyone there? I don't see anything in chat. Just want to make sure people can hear me and see me. Okay, perfect. So why migrate to ClickHouse? I talked about that a little bit. I'll just try to make it very, very clear. I was giving a training about migrating from Postgres to ClickHouse, and I don't know, like 1 hour and a half in, someone is like, okay, but why should I migrate? And I'm like, I thought you were here because you already knew why you should migrate, but maybe that's not the case. So data usage limitations, right? Constantly trying to avoid querying your own data because of costs or because it takes too long. So it's just not too valuable to have a data warehouse like this. Query latency, if you really have like a dashboard and analytics stuff, like that's really not going to work, okay? Cost, it's all associated, right? And ClickHouse, what you're going to get is like designed to store and query massive data, both in storing and pricing, designed to be fast. So you're definitely going to see your queries being much, much faster within ClickHouse. And I'm going to show you a few examples. And cost as well, because it's fixed and you know exactly what you're going to pay and you're going to make the most out of the data. Like when you really have a lot of queries, you can really reduce cost by a lot. Here's just an example of Adevinta. That's one company. We have another company that just migrated we're going to write a blog about, and they just managed to like cut costs in half. So I talk a lot about cost. Here's a slide that tries to summarize that. So this is the BigQuery UI. There's a query running. You usually have the job information of how long it took. Oops. There is this slot milliseconds where you actually have like how long it took to run the query, not in terms of our time, but in terms of resources. So if it took like 5 machines, 1 second each, this is a total of 5 seconds to run this. In this case, it took like 6.91 hours of compute, which they call like slot time. And sorry again. And there are a few like plans like Enterprise Plus, pay as you go, 3-year commit. So here's trying to summarize the cost for running this specific query. And you can see ranges from $0.2 to 0.6. And at ClickHouse, it's slightly complicated to calculate and compare to BigQuery because we just have the service and we just charge you by the month and by the infrastructure. But if you imagine that the cost for the infrastructure is 0.57 and you multiply by basically what you really need and you calculate like the query, then you're going to end up with like 0.046 cents, which is about 5 to 15 times cheaper than running the same thing within BigQuery. Again, if you run a single query a month, BigQuery is going to be cheaper. There is no discussion there, right? But if you're actually running multiple queries and concurrently and in parallel, then ClickHouse definitely shines. And one thing that I think is really important as I was studying and really learning about BigQuery is data warehouses, they should encourage people to query their data, not the other way around, right? So does it make sense to invest in a data warehouse that folks are afraid to use? Earlier today, I was preparing the demos and I executed a new query and it just took like, I don't know, 6 minutes to run. And I was like, oh my God, what did I do? How much is this going to cost me and the company just for this kind of simple query that I'm using to demo, right? And yeah, a single query just cost me, I don't know, around $7 or up to $21, just a demo query. And the fact that you don't know and that you're always afraid, that's not what you want from your data, right? You want to be free. You want to really be confident that you can run queries, experiment things, try different ways to query the data, to understand the data without have this burden of how much is it going to cost you. So Salohi, you send a message to hosts and panelists. If you can change to everyone, that would be great, so everyone can read. Hello, can you later and elaborate more the part you might have limitation with ClickHouse if you have lots of joins? What do you mean with lots of joins here? Yeah, I'll definitely elaborate throughout, and I have slides for that. That's a great question. Let me just copy and paste here so we don't forget and everyone can see. Good. So yeah, we see people coming like, my current analytics is not fast enough. It doesn't scale. Yeah, ClickHouse is up to 95% faster. The amount of data stored is just too much. Okay, ClickHouse is more efficient and usually requires less storage. I would love to have more flexibility when writing queries. Yeah, we do support standard SQL, but we actually added a lot of extensions and improvements with lambda functions, high order functions, and just makes the experience of writing queries better. SQL is great, but what if I want something more powerful? Yeah, on top of SQL, we add a lot of data analytics tools. We have more than 1,300 data processing functions, more than 150 pre-built aggregation combinators. And as you combine them, like this just gives you a lot of flexibility and possibility. Oh, I hardly need arrays, but they're just too complicated to use. ClickHouse has a rich array support. We have a lot of different functions. You can combine those array functions with other aggregate functions, and you can write like queries in way shorter syntax and just get what you need way faster. My data warehouse must support multiple file formats and sources. Yes, ClickHouse gives you world-class interpretability. Like we have native support reading data like many different file formats, most data sources out there. You can just plug them into ClickHouse very, very easily. And finally, it used to work fine. Now it's just too expensive. I can only analyze a subset of the data. I need to let data go because it's just too costly. Yeah, we're way more cost effective. Great. So let's talk about the data set we're going to see throughout the course. We're going to use the Stack Exchange data set. They release data dumps every now and often. We have this data set in GCP as a public data set. Here's the link, and I'm going to share the slides later on. We use a subset of the data. We're just going to focus on the posts, users, votes, and badges. That's mainly what I'm going to focus on. And the data set is very straightforward, right? Like hopefully everyone here is familiar with Stack Overflow, the Stack forum that you can ask questions and get answered to your problems. So a post will have an ID, it will have a type of post. Is it a question? Is it an answer? What is it about? Might have a parent, might have a owner, like the user that created the post, the last edit, like things like that. You have the users, they're basically people that are adding things and creating questions, giving answers and stuff. You have the badges, so as you're a user and you answer questions or you do things within the forum, you just start earning badges through time. And you have votes. People can vote on the questions they like, the answers that actually answer the question the better. And it's just everything model here, not too complicated. Usually an ID, a user ID, the name of the badge, or like the user ID that actually voted, the post ID, things like that. You can actually have this kind of relational, okay, that's interesting. I thought I had changed this slide. Sorry. Yeah, okay, I just changed the other one. This is a very relational data set. So you have posts relating to votes, users relating to badges and posts, post types and vote types. There's actually a mistake here, like this connection between users and votes actually doesn't exist. So here it's actually better. So the data set is around 34 gigabytes of data, 46 million for badges. Like the biggest table is votes with 236 million rows. And this is what I'm going to use to show you a few things. So let's go to a demo. Actually, let me do this and go here. I want to start from here. Okay, so this is the public data set. Is this big enough? Do I need to increase the font size for this? Actually, just on this side for now. Hi, anyone there? Font's fine. Okay, perfect. Thank you. So this is the public data set, Stack Overflow, and we have the badges table here within BigQuery. I can check the schema, ID, name, date, the user ID, and those two, I don't really care. You can look into the details. You can see like the uncompressed size, that's about 2 gigabytes of data. And you can also see the compressed size, which is about 500 megabytes of data. Okay? And this is a very straightforward table. And what I'm going to do here is I'm actually going to run a few queries. It's not a very large data set, and that's on purpose. I don't want to run a query that takes like, I don't know, 6 minutes to run and just wait with you all here. So the idea is to actually play with a smaller data set that we can see how it goes. So I have a few queries here. And the first query is, so what is the average number of badges per user? So I'm just going to run this query. It's counting the total number of badges and dividing it by the number of users we have. And that's just going to give me, yeah, okay. So that's around 5 badges per user. That's what we have. This, oh, okay. That's not going to help me. I thought I had disabled that. They just enabled it again. So cache was enabled in BigQuery, which means it's just getting the response from the query that I executed earlier. Cache is a grade 2. That's true. There are 2 problems with caches. One is if you are actively writing, you're basically like aging your cache. So the cache actually doesn't have the correct information anymore. Second thing is it's really hard to compare based on cache. Okay, so what we usually do is we disable cache on everything we're testing and comparing and just run things without cache. So looking again, this query, very simple query. Come on, I got a count and divided by the number different kind like distinct users that I have. This took 7 seconds. Okay, it read about 350 megabytes of data. And the slot millisecond is this. And I built a calculator here that to get started is not going to make a lot of difference because those are queries on very small data sets. But I basically calculates the cost on depending on my plan. So something between 0.003 cents to 0.0001. Actually, not cents, right? It's $0.001. And yeah, so there is another query here that I'm going to run. This is basically looking into at least how many badges do half of the users have. So I'm doing an analysis on badges to see, like, are people really getting those badges? Like, is it something important in my website and the forum? Is it something we should promote more or change the way we do? And I'm just trying to understand. So again, it's taking about 6-8 seconds, 350 megabytes of data, took a little bit less. So very cheap, query to run, cost me depending on like almost like nothing. But still takes me 6 seconds. Can you imagine the dashboard running live and someone's is just in the dashboard, and then I refresh the dashboard, and then one of the queries takes 6 seconds to run. The other one takes 7 seconds to run. And now you're sitting there waiting for, I don't know, about 8 seconds to just get the result back of a very simple dashboard that's just going to tell me that, okay, 50% of the users have 2 badges, 75, 4 badges, at least 4, 90% at least 10 badges, and 99% of your users, actually the other way around, my bad, 1% of your users have at least 61 badges, right? That's not going to play like really well. So this is another query. This is going to be a join query. So what are the top 10 users with the most badges? I just want to see like the most active and like really rewarded users. This is going to join badges with users looking by the user ID. And there it is. This is my list of the top 10 users in Stack Overflow in terms of badges. One of them actually has 19K badges. It sounds wrong somehow, but it's in the data. I'm not sure how it happened, but it did. Again, this took around 4 seconds, read about 700 megabytes of data, and that was the cost, which is going to be very similar to this first query here. Okay, good. So, John Skid is a legend, yeah. But like it's really skewed, right? It's like more than double on here. Great. So, all right, I'm not happy with this latency. That's not what I want. I want to migrate this to ClickHouse. What do I do? So to migrate, it's pretty simple. All you need to do is export the data you have in BigQuery. So I'm doing an export, I'm doing an export data to a specific GCS bucket. That's the object storage for GCP. I'm writing to badges, star, format parquet. I'm going to override everything so it's all live. And all I'm going to do is a select star from badges. Okay, so I'm going to run this. This is going to export all the data into my GCS bucket. So actually, I always, thanks. Yeah, you can just see here, 2:30 p.m. my time, October 23. It just wrote all the badges here. It's done. That was exported. Great. Now, what I'm going to do is I'm actually going to go to ClickHouse. And ClickHouse has this idea of services that I was talking about. And as you register to ClickHouse Cloud, you can create a new service. You can give it a name like demo BigQuery. You can select a cloud provider, the region you want, production, and you can also define the size. And the size can be defined with a minimum and a maximum value. So what I would do for these types of tasks and comparisons, I would set the minimum and the maximum to the same value. It always gives you 3 nodes in production. You can have more than 3, but then you need to contact support for that. But I would advise you to start with just like this. This is the idling options that I was talking about earlier today. You can define like, okay, I don't want it to go down for an hour. And then all you need to do is create service, click create service, and then it will start provisioning. Okay. I actually already have my own. If I go to settings, you're going to see that I have exactly the same thing. So 1 hour here, like minimum and maximum to the same. So I don't need to scale because I'm just testing. I want it full speed. And I'm going to run a few things. So I currently have already all the tables that I talked about ingested. Let me know if it's too small. So I have badges, posts, users, and votes. I'm not going to take the time to go through all of them, but I will do for badges. So I'll just drop the badges table. So we have nothing, right? And we exported the data to GCS, as I showed you earlier. And now I want to add this data to ClickHouse. So I'm going to create the table badges. If we go back here and look into the badges table, you're going to see an ID, a name, ID, name, date, user ID, class, and tag base. So exactly the same thing we had. The integers are still integers. The day timestamp is still a date time, and name is still a string. I'm going to talk more about low cardinality later. Every table in ClickHouse has an engine, okay? And the default engine for you to write data into ClickHouse is the merge tree engine. We also define a primary key. I'm going to talk more about that in a bit, but it's not the primary key you are used to. It's not uniqueness. It's just the sort order. Actually, if I had here order by, that would make more sense for you to get started. It's how I want the data to be sorted in disk. So I'm going to create this table, and I'm going to insert into badges all those Parquet files that I just wrote. And I'm going to use the S3 table function to go all the way to GCS, get all those files, stream them into ClickHouse, and write them into ClickHouse, okay? And the best thing about the S3 cluster function, and not only S3, and yes, I'm using GCS, but the S3 table function works for both, is that the cluster allows me to parallelize reading, streaming those files in, okay? So I'm going to run this. This is going to take a few seconds, actually. I think we have about 48 million. So 27, 35, 44, boom. There you go. So all the data is now in ClickHouse, and we can start working with ClickHouse. I'm actually going to make this bigger for a second. So this is a way to see the size of the table. So I'm going to run this so we can compare. By default, it gives me in a MIB, okay, instead of just MB, which is different from BigQuery. So I added this multiplier here just so we are comparing exactly the same thing. So we have the data here in 340 megabytes. That's the compressed size, and about 630 the uncompressed size. So yeah, this was 500 something, and this is like 2 gigabytes, and now it's like 600. So it's 3 times difference just in terms of storage of the uncompressed. And for the compressed one, that's probably going to be around, I don't know, something 40%. Great. So let's go to the queries now. Any questions so far? You're all very quiet today. All good? Everyone there? Everyone live? Yeah, great. So I'm going to run the same queries, right? And I'm going to use this setting to disable cache. As I said earlier, I disabled cache from BigQuery. I'm disabling cache from from ClickHouse as well. So I'm going to run the first query. What is the average number of badges per user? And this takes 440 milliseconds to run. Okay? Not sure if you remember, but this one was taking something like 7 seconds. Yeah, this is a great question. I'll answer that in a bit. Okay, let me just finish here. I really like your question. I'll get back to it. So this was about 6 seconds, and now we're talking about 440 milliseconds. And this is what it took before, right? So if I go back to my calculator here, to be honest, it's not going to make a lot of difference here, but it's about 2 times to 5 times cheaper, okay, to run a query in ClickHouse. Again, we don't charge by the query, but if you just think that you would have like a active number of queries, that's the difference. And this is a very small data set. This gets like very, very different later on. I'm going to run the second query. again, 500 milliseconds. In ClickHouse, BigQuery was taking something like, I don't know, it was 7 seconds, 6 to 8 seconds. Again, this is not fast enough, in my opinion, to have in a dashboard. I think we can still optimize this a little bit more, but that's another course and another discussion. But just going from 6 seconds to 500 milliseconds is already great, right? And now the join. You remember that I said that ClickHouse has some issues with performance in terms of joins, right? So let me run this query and see what happens. Wow. Okay, I was not lying to you. And ClickHouse does perform way slower, not way slower, but slower than BigQuery for this one. So I'm not sure if you remember, but that one takes, I think, around 4 seconds in BigQuery. Oops, job information. Yeah, 5 seconds. So 5 seconds, I would say, is about the same. And I'm not happy with that. I don't like the same as BigQuery. We are fast. We focus on being fast. So what can I do here? So this is a simple join. Like it's like the top 10 users, but I need to get the display name. I don't have the display name in the badges table. So I need to do a join with users. And that join is just to get the display name, right? So I'm going to optimize this join query for ClickHouse. And the way I optimize this join query for ClickHouse is I actually calculate the top 10 users and the badge count for them. So I have only 10 results. And then after that, I get the users table, and then I join the users table with that very small result table of 10 results, and then I give back the final result. Okay, so it's a way to write a slightly more complicated query, but to actually do the math and the calculation before we do the join. Okay, so I'm going to run this. And boom, I'm down from 5.8 seconds to 0.808 seconds. Okay, so 880 milliseconds, that's how long it took the query that was taking 5.5 seconds by just doing a small query tweak. Really, we don't have a lot of time to stay here. I really want to cover a lot of different things still, but like it was a small change. You might be asking yourself, okay, but what about this same query, the same change in BigQuery? Yeah, I do have it because I was like, yeah, of course people are going to think about that. I changed the query. You probably want to run the optimized query in BigQuery as well. So let's do it. With top users as, I do the calculation of the top 10. Then I do the join here. So let's get this and let's run. And at the end of the day, it takes the same 5 seconds. All right. So it's all about speed for us. It's all about real-time analytics. And we have a course where we go into, okay, like 1 second, 0.8 seconds. It's not good enough for me. How do I get better and faster queries in ClickHouse? This is not the course for it, but it's definitely showing you that just by doing a small massage, I can really speed things up. Like we're talking about 5 times faster than BigQuery without doing a lot of effort in here. Okay, so that was my first demo. Any questions on the demo? I see a question in chat and I'll answer it right now. So if you have questions about what I told so far, please fire them away. Can I insert data directly from BigQuery with storage bypass? So I showed that in order to get data into ClickHouse, come on, get out of there. I export the data to GCS, and then I very easily ingest this data to ClickHouse. So The quick answer in terms of just using ClickHouse Cloud, no, there is no connector from ClickHouse Cloud to BigQuery directly. Okay? You would need to use an external tool that can read data from BigQuery and write data to ClickHouse. We have been working on data sources here. So we have something called ClickPipes. And ClickPipes connect to a lot of different things, and like Amazon S3, GCS, but also this key Kafka, right? And one thing that you could do is to actually get data from BigQuery into a Kafka and then to ClickHouse, and then you could use just the UI and connect directly from here. Or you can write your own script or something like that. But from experience from our users that have migrated from BigQuery to ClickHouse Cloud, they said that starting like this, it's actually a really, really good way to get started, to do the first initial heavy bulk migration, and then find another way to keep things moving. There is a Q&A. Q&A is very hard. Okay, it's off topic. Yeah, okay. Then I'll just take it later. So loading data from BigQuery. So there are two options, right? The bulk export, which is exported data to files in GCS and then import those to ClickHouse. And the change data capture, which must use an external tool or script. So right now in ClickHouse Cloud, we don't have this built-in tool to read directly from BigQuery. You would need to do this two-step. All right. So important to know is that, let me go back here. In ClickHouse, we have this thing called table function. And the nice thing is, like here I showed you how to insert straight away. But actually what I could be doing is what I'm doing, but it's hidden, is that I'm actually just streaming data right away from the cluster, right? And I don't know, I could do a count, or you could do anything. So this is literally going to the GCS, streaming the data in, and doing whatever you want it to do. This is what we call a table function. And there is a GCS table function that works just fine. If I want to change this to GCS and run it again, oops, sorry. It's just going to stream and read the data. And you can insert into GCS as well. You probably need to provide credentials so you have the rights to write. And you can describe the file. You can do a lot of different things just by using a table function without actually writing any data to ClickHouse. So it's a great discovery tool, migration tool. Oops. The S3 function is exactly the same function, is exactly the same function as the GCS. Actually, the GCS is just an alias to the S3 function. And as I said before, the S3 cluster actually allow us to parallelize because we use all the nodes in the cluster to process this data. Okay? So it's just going to make things faster. Instead of a table function, we also have what we call a table engine. You create this table in ClickHouse, this table exists. And from now on, sorry, the scrolling is killing me. I just touched my mouse and it scrolls away. Oh boy, yeah. So this is just doing a count from GCS votes. But GCS votes is not a table with data in ClickHouse, is a table pointing to GCS. So it's going to go to GCS with all the details that you provide here. It's going to get the data, do the count, and provide you with the result. Okay? All right, loading data from BigQuery, I showed you that. So you export the data, you create a table in ClickHouse, you import the data from GCS to ClickHouse. That's the simplest and fastest way to actually just get the data without using any ETL tool or just doing synchronization. Okay, so it's time for a lab.